blocks. The numerator is annual variance. It's what I call the big block of variance. The reason why I think about it this way is because I find it easier when I know that implied volatility metrics are annual numbers to think about using that in an annual way. So what I mean by that, and you'll notice, right, this is the same formula that we've been looking at. Daily standard deviations equals implied vol times stock price. So the top of this is the big block of variance. Think of the numerator as the big block of variance. The reason why is because you're taking an annual number, the actual implied vol, and you're multiplying it by the stock price. When you multiply those two numbers together, what you get is the actual annual variance. It is the implied volatility, which is an annual number, times the asset prices, the underlying asset price. And what you're doing when you do that is you're giving yourself the expectation for how much this thing should theoretically, based on the implied volatility level, move over the next full year. This is your starting point for expected movement. Given any implied volatility level, you can estimate how much a stock might move over the course of the entire year. That's the big block of variance. And then you can slice it down into smaller pieces, smaller expectations, depending on whether or not you want to take that whole big block of variance and say, okay, that's $20 of variance for an entire year. How much of that can I expect today or tomorrow? Or how much of that can I expect this week or next week or any random week or any month, right? That's how we're dealing with this as an expectation that goes for the entire year, and then we break it down into smaller chunks. So in this example, we're talking about an implied volatility of an option that's 20%. If implied vol is 20% and you're dealing with a stock that's $100, your annual variance, the top of that equation, is going to be 20 times 100. In this case, the 20 vol you actually convert to a decimal, so 0.20 times 100, and that gives you an annual variance of $20. When you compute annual variance, or when you compute variance in general, variance doesn't tell you anything about direction, nor do standard deviations when you start to talk about them. These are really just measurements of movement away from the mean. That's all they are. And